Okay, the problem, let me read the problem again. It says that you have household bleach, a 5% solution of household bleach, which is sodium hypochlorite, correct?
Yes.
Hypochlorite is ClO. Chlorite is ClO2, chlorate is ClO3, and perchlorate is ClO4. It's going to break down to these ions. This is the ion. This is the salt of a weak acid. Therefore, this ion is going to be in water because this is a sodium salt, so you get 100% dissociation. So this concentration, excuse me, is going to be the same as this concentration. It's going to be the same. It's 1-to-1, correct? You see that? Yes. Now, I know the starting concentration of that. Now, that's going to form hypochlorous acid, and as a result, you're going to get hydroxide in solution. You know that by now you should. The salt of a weak acid makes a basic solution. I want to know what the concentration of this is, and I want to know the resulting pH of a 5% solution. The density of water is given as 1 gram per milliliter. 5% solution by mass, m over m. That's going to be 5 grams over 100 grams of water, which is the same as 5 grams over 100 milliliters, because 1 gram is 1 milliliter, 1 gram per milliliter, the density of water. Therefore, 50 grams per 1,000 milliliters. Now, if I convert that to molarity, what's my starting molarity of the sodium? What's the starting molarity of my sodium hypochlorite solution? Okay, this is going to be a solution of sodium hypochlorite and water, correct?
Yes.
I'm making a 5% solution up, correct?
Yes.
Yes or no? Okay, so what's it going to be? What's it going to be? How do I do that? What's the, can you put your thing in there? What's the gram molecular weight of sodium hypochlorite? 23, 35, and 16. What is it? Anybody? Nobody's here today? Trust me when I tell you, you want me to do this problem. Do you want me to not do it? I don't have to. Well, what is the gram molecular weight for sodium hypochlorite? You're going to keep that to yourself until I threaten you? What is it? 74.5. It's 74.5 grams, gram molecular weight, right? Right?
Yes.
All right, so how many moles is 50 grams? How many moles is 50 grams? Why don't you help me out? How many moles is 50 grams? I want to convert 50 grams to moles. What do I got? Anybody? Nobody? Nobody in here. Nobody in here, which has the honors 10th grade English classes in here. Nobody in here can convert from 50 grams to the number of moles. Jad, you can't do that? You can't do that. Are you serious?
0.67.
0.67. Is that what you get? 0.67? So it's going to be 0.67 moles per 1,000 milliliters. So what's the starting molarity of the solution? What's the starting molarity? Anybody? What's the starting molarity of the sodium hypochlorite? What is it? If it's 0.67 moles per 1,000 milliliters, what's the molarity? 0.67 molar, right? Yes? Okay. Now, so let's get rid of this. Okay. So, this is going to be 0.67 molar. Are we all right with that?
Yes.
Now, Now, is that going to break down to this? I want to find the concentration of these, correct? This is the concentration of this, right? So I want to find the concentration of these. What can we represent, or what is the book? What's the technique used to represent the concentration of these? What does it use? Nobody? Nobody? It's a little. It says X, right? Doesn't it? Why do they both get X?
Because together they equal.
No. Because isn't this going to take on a hydrogen to form hypochlorous acid? Isn't that true or no? Yeah, it is, right? Right? So I'm going to wind up with a certain molarity of this, correct? By subtracting moles. We're assuming it's going to be, let's say, 1,000 milliliters. It's going to be one particle per one particle, right? Isn't it really the number of particles that we're looking at, correct? And haven't we been, has anybody looked at any of the videos? No? Nothing? Yeah, it's exciting. Okay, good. All right, so what's the, is this going to be a KB expression or a Ka expression? There's going to be a base. It's going to be a KB. What's the KB expression, therefore? The KB expression is going to be, remember, it's the product of the, you've read this? No? Hydrolysis of salts. It's going to be the product of the molarity, the product of the concentration of the products. That's going to be HClO over OH over, sorry, HClO, right? Isn't that correct? You're going to put in, what for? What are you going to put in?
The value that this point is.
Yeah, you're going to put X here, X here. What's X times X? What's X times X?
X squared.
X squared. Do I have to subtract X from that?
No.
Why?
Because
What's KB?
that.
No.
No, it's all-
That is not KB, that's Ka. What's KB? What's the equation? What's Ka times Kb equal?
1 times 10.
1 times 10 to the negative 14th, correct? So what is 1 times 10 to the negative 14th divided by 3.5 times 10 to the negative 8th? What is it?
Divided by
1 times 10 to the negative 14th divided by the Ka. What is the value?
2.86 times 10 to the negative 7.
2.86 times 10 to the negative 7, right? Very small, isn't it? Very small. Is it really going to make a difference? I have another worksheet, by the way, where it's not going to make a difference. I'm telling you, it's just not that big of a deal. So why go through the headache of a quadratic, right? Why go through the headache with a quadratic? Clear? Okay. So this is just going to be 0.67, right? And then that's going to equal this, correct? 2.86 times 10 to the negative 7th. Okay? Now, can I erase this part? Is that okay? Can I erase that? Yes or no?
Yes, yes.
Okay. So now what happens as a result of that? What happens?
Divide 0.67.
So, yeah, you're gonna solve for x, right? So you're gonna multiply through, so 2.86 times 10 to the negative 7th, right? Times 0.67. Do that much and tell me what you get.
1.8.
Do that much. Let people do it before you call it out, okay? Let people do it. Anybody get it? Gabby, you got it? You don't have it yet. So let me get this straight. I just want to double check here. Check my facts. So you can't go 0.67 times 2.86 times 10 to the negative 7th. Is that correct?
No, in fact, we have it right here.
Okay. All right. Everybody close your laptops. There's no reason to have them open. I want everybody following me. Trust me when I tell you this is important. So what's the answer, Gabby?
So x squared is equal to 1 point.
This times this.
Yep.
Not square rooting it yet. I simply want.
I know, I said
Point-
x squared is equal to
Oh, my apologies. It's a hearing thing. Carry on.
1.9 to the 10 times 10 to the negative 7. 1.92. Okay, sorry.
1.92.
Sure. Yes.
Is that correct?
Yes.
And it's times 10 to the negative 7th.
Yes.
Okay. So now take the square root of both sides. What do you get?
X equals 4.37 times 10 to the negative.
Who said that?
4.38.
What, Victoria, is that different from what you said?
Yep, she just got 7.
Whatever. All right, just give it. All right, Victoria, what did you get, hon?
4.38 times 10 to the negative.
4.4.
Is that right?
Yes.
Okay. And that's going to be a concentration. And what's that going to be the concentration of?
The big.
The hydroxide, right? Right? Do we care about the concentration of the acid? Do we really care?
No.
Not really. If we were doing a buffer problem, we might want to, but I don't. It doesn't really matter. So it's going to be it's going to be OH, right? Correct? You got that?
Yes.
Yes.
So is it the same value for the acid?
Is it the same value? Yeah. Mm-hmm. Yeah. Yep. This is the same. Remember, I had the expression down. They were both X, right? So now, can I erase this? Okay. Can I erase this? Okay, now. Can you get the Neve? This is the OH concentration. How would I get the H plus concentration? What would I do? Do you remember I showed you in math class? Negative 14. Excellent. Excellent. You'd say the H ion concentration equals 1 times 10 to the negative 14 divided by 4.38 times 10 to the negative 4. What do you got? Right? Okay, what do you got? What's your value? What's your value? Say it again, Nort.
2.28 times 10 to the power minus 11.
Is that right? Is that what you said?
Yes.
All right, good. So now we have the OH concentration, right?
Yes.
We have the H plus concentration.
Yes.
Now let's do the. Now what would the POH be?
The key is
What's the POH?
10.6.
So it's going to be negative log of that, right?
Yeah.
Right? No, sorry, negative log of that, right?
Yes.
That's negative log of that, right? Right? POH equals negative log of OH. Right?
I can.
So it's going to be the negative log of this, right?
Yeah.
So what is it going to be?
3.3.
Is that what you got?
3.358. Yeah. If you want 3.358.
Okay, so the POH, just give me 2 decimal places.
3.35. 36.
3.36?
Yeah.
Okay, good. And what would the pH be?
10.64.
10 point what?
64.
10.64. Easy?
Peace.
Well, all right, fine. It's not terrible, right? Isn't it so much easier not doing the quadratic formula?
Thank God.
You have to be able to do the quadratic formula, but all right. So this is one problem. Let's just pretend for a moment. Let's say I gave this problem on a test. So instead of one question, you know how I don't like to give partial credit? What I would ask is, you got to do it anyway, right? I would ask, what is the KB? What is the H plus? What is the OH? What is the pH? What is the POH? You'd have to give me it all. Even though it's asking for what? The pH, or it's asking for the pH and the OH. I'd ask you for everything. Because you got to do it anyway, right? So why not get credit for it, right? Cool? Okay. Because if you made a mistake, if you got the OH and then you screwed up with the H plus and the pH, at least you'd, with the POH and the OH, at least you'd get some partial credit, right? All that work, right? Yes? Okay? So is this dangerous?
No. Oh, yes, it's, yeah.
Yeah, it's pretty gnarly stuff. That's not great stuff. That's getting a little crazy. Okay? You could get burned with that.
What about like 13?
Excuse me?
What about
13
13?
is something that you want to say, no thank you.
Why?
Because the closer you are to 14,
Yeah.
the more dangerous it's going to be. The more basic it's going to be. Excuse me?
Do we use it to clean grades and stuff? Like more effectively?
Yeah, and that's true, but A, how many times do you have to clean a drain? B, use a plunger. C, call a plumber. D, if you have to use it, I think I've used it maybe 3 times in my life. Okay? It's always important to keep that drain cap on. Helps a lot. But I use, I've had, clogged drains here, and I just use a plunger. The hard thing about a plunger is doing what? What's the hard thing about a plunger? Is the safety drains. In other words, if you have a sink, right? Let's say you're looking down at a sink, right? Here's the faucet and here's the drain.
Oh yeah.
If you're plunging that, you get this safety drain here, right? In the back, up underneath the countertop. So if you plunge that, it squirts out there. So you gotta make sure that's held there. And then you have the drains in the floor, right? And you gotta make sure that, you have 1 foot on that drain and 1 foot on this drain, and you get your neighbors in, and it's like put your foot on a drain party while you plunge the sinks, okay? Yeah, but because if you don't, then it just doesn't work, right? But plungers are wonderful. Wonderful.
How much do
Wonderful.
they get paid for?
What? How much do I get paid for plunging?
No, like plungers, like.
Plunders? No, or plumbers. Is that like a Canadian thing? Plunders?
No.
Plumbers.
Yeah, plumbers. How much do they get paid?
I was comparing notes with a plumber in New Jersey. And I must admit that it's a more physical job than being a teacher, although I'd like to see that guy do what I do during the day. But he made about 10% more than I did. And I was at the top of my guide.
What?
Yeah, the plumber made more than I did. At least 10%. For a younger teacher, he makes twice. Yeah. Plumbers make serious cash.
Plumbers?
Nobody wants to be a plumber. Who wants to be a plumber? Nobody wants to be a plumber. It's hard work. It's hard work. It's not an attractive field.
If you have an apprenticeship in order to you'll go to school for it.
Gabby's attractive in anything she does.
Gabby would be, yes, that's correct. I could see her as Gabby the plumber. Yes, that's walking around with that giant wrenches and plungers. Okay, so we're off.